All right, guys, so we're going to continue solving systems of equations. And again, this topic is review because you solved linear systems of equations and inequalities in Algebra 1, but we're going to kind of apply this now to some of the functions we've been using in Algebra 2. So for example, this function right here, this equation is a parabola, right? And this is a circle. We're going to be using systems of equations and solving them when one of our equations is one of our new types of equations, all right? So it's still, the topic is review, but we're going to be applying it to some newer types of functions. So, all right. So if we are solving a system of equations like either of these, and I'm just going to make a note off to the side, if we're solving systems like this where one of them is a line and one is a parabola, or one's a line and one's a circle, or if we had one where we had one that was a parabola and one that was a circle, any system where there are two different types of equations, we would use the substitution method. All right, so it might not be a bad idea to make a note of that, and that's what's going on here too. So we've got a line parabola system, we've got a line circle system. Let's use substitution in these cases. And even furthermore, if you really want to make a note of it, the thing you're always going to substitute will be the line or the lower order function. So you would take your line here, which is a very simple function, and plug that into your parabola. Over here, you'll take your line, which is a simple function, plug it into your circle. So whichever is the simpler of the two, plug that in, right? So I'm going to take my 2x, or negative 2x plus 4, and I'm going to plug that in to my parabola wherever I see y. Okay, so I've just replaced that y with a negative 2x plus 4. And now I'm going to solve this thing. So I'm noticing that the type of function I have here is a quadratic. So I want to set it equal to 0. So I'm going to move these pieces over to this side. All right, so now I'll have a 0 over here equals negative x squared. 4x plus 2x is 6x. And negative 1 minus 4 is negative 5. I would love to double bubble this, but the problem is right now, we have a negative 1 in front, and I can't do that unless that's a positive 1. So right now, I think I'll just divide everything by negative 1, just to get rid of that. And 0 divided by negative 1 is still just 0. But now I have a positive x squared minus 6x plus 5. All right, now I can double bubble. What two numbers add to negative 6 and multiply to 5? That's going to be negative 3 and negative 2. So my x solutions are going to be 2 and 3, all right? So remember now, if you picture this, what I've got is some parabola that looks like this, right? And some line that looks like this, right? So it could be here, it could be here and just grazing our parabola, so maybe there's only one solution, but it also could be here and have two solutions. So in the event that it has two solutions, what I would find is that these two x values each have y coordinates. And I am seeing here that there are two solutions, right, because I have two x values. So if there are two x values where this equation is equal to that equation, then I have two solutions. So what I'm going to do is I'm going to plug each of those back into the line, just because it's the easier function. So I'll have y equals negative 2 times 2 plus 3. Oops, sorry, no, that should be a 4. All right, so that's negative 4 plus 4, which is 0. So one of my solutions is 2, 0. And then I also have y equals negative 2 times 3 plus 4. Here I am finding my second solution. So I also have 3, negative 2. And the way that I would write those as solutions, I would say I have these two solutions. All right? So that's how you handle a line and a parabola. The way that you handle a line and a circle is very, very similar. Again, I'm going to take the easier of the two, so this one looks pretty easy, and I'm going to take that and plug it in there for where I see a y. So I have x squared plus, and instead of y, I'll have x minus 3 equals 29. So to solve this now, I'm going to have to blow this up. I'm going to have to expand it. So I'll have x squared plus x minus 3 times x minus 3 equals 29. You guys should be able to follow me from here to the end, so I'll just skip ahead. And again, if you need to see these steps a little slower, pause it and take a look and see how I went from one step to the next. So at this point, again, I have a quadratic. I've got to solve it. It's set equal to 0 already, but again, the issue here is that that's a 2. So I've got a couple options. I could throw this thing into the quadratic formula, or I could make that first term be a 1 and divide everything across the board by 2. Now I have x squared minus 3x minus 10 equals 0. And now I can double bubble. All right, so x is going to equal negative 2 and 5. And again, I can just go ahead and throw each of those things back into whichever of the two is simpler. So my two solutions are going to be negative 2, negative 5, and 5, 2. And again, you can see how there would be two solutions, right? If I have a circle, I could have no solutions. I could have just one solution. I also could potentially have two solutions. So here we're in the situation where we have two solutions. Now let's move on to systems where we have three functions. All right, so we've got three of these things. I'm not going to talk about whether it's linear or what type of function this is, because this isn't something that we care so much about. We do care about solving them. We don't care about what these look like yet. And we won't really get into what these look like in Algebra 2. But you do have to be able to solve them. So because they're all the same type, it's not quite the same as when we were dealing with these other two situations, right? So I said if the equations are of different types, we should use substitution. Actually, the way that it's going to work out is if they're the same type, we should use elimination. Okay, so we can see there are no x squareds, y squared, z squareds. All of it is just x to the first, y to the first, z to the first. Actually, there is one correction that you need to make. This x should be a z. So why don't you guys all change those to z's. All right, now we can solve this thing. So here's what I'm going to do. I'm actually going to create two systems of equations that are similar. So I'm going to pair these two up, and I'm going to pair these two up, or these two up, right? I'm just going to make two pairs. So what I'm actually going to do, I think, which is going to be a little easier in hindsight, is take those two and the first two, and I'm going to stack them on top of each other. Once I've done this, these are essentially two systems that are going to give us two equations. With those two, we'll be able to solve this thing. But the problem right now is we've got three of these, so if we do substitution, we're just going to be substituting like crazy. So what I'm going to do is I'm going to try to find a way to use the elimination method on these so that I eliminate one of my variables. And this one is set up pretty easily for us to use z. So if I add here, z is going to disappear, right? I'll get 8x, I'll get negative 2y, z's cancel, and I get 50. Over here I can also add, I'll get negative 2x, 5y, z's cancel, and I get 1. That first step is really necessary because now we don't have to worry about having three variables anymore. I've eliminated one of my variables. And now this is just a system of equations that you could solve using substitution or elimination. But again, I would recommend elimination. So I'm going to go through the steps pretty quickly for that. Let me just set it up. So I'll have 8x minus 2y equals 50. I'll have negative 2x plus 5y equals 1. I'm actually going to multiply this one by 4. All right. Okay, so now I can use addition to cancel my x's. So now I'll have 18y equals 54. Y equals 3. Good. So let me carry that over to whichever of the three functions I have here is easiest. Okay, so I've chosen the first two because it looks to me like those are going to be the easiest numbers to deal with. Notice that I've substituted instead of my y, right? In my first function I have a y in the second one as well. I'm using 3 now. And I've just created a system of equations that I should be able to solve because I know what y is, and now I just, again, have two variables. So that's going to turn into... Okay, so I can use elimination on this by adding, because the z's are going to cancel. So I'll get 8x equals 56. Therefore, x equals 7. All right, I've solved for y, I've solved for x. So I just have to plug this thing into the next simplest function. I'm going to take the top one. I think the top function is going to be the easiest. So instead of 2x, I have 2 times 7. Instead of y, I have a 3. And I do still have plus z equals 15. And I just have to solve. So z equals -2. So my solutions are x equals 7, y equals 3, z equals -2. Another acceptable way to write this, at this point, I guess you could do this. Because when we have points in 2 dimensions, we write our x point first and our y point second. This, however, would be a point in 3 dimensions that has an x, a y, and a z coordinate. All right? So I know this is a little long. We are going to be practicing a lot of these in class, because this is the type of stuff that shows up on the Common Core exam a little bit more often than the other two, but these have appeared as well. All right? So be prepared to practice a bunch of those in class, a lot of elimination method. All right, guys. See you tomorrow.